Welcome to Corpstruction, a show about the missions, activities, and employees of the U.S. Army Corps of Engineers, Tulsa District. Today we have Russell Wyckoff, who's a senior hydraulic engineer in the Dam Safety Production Center. The Dam Safety Production Center actually falls under the Southwestern Division, but it's located here at the Tulsa District. Russell provides oversight of technical hydrology and hydraulic studies in the areas of dam and levee safety, construction, and operations. He also engages in USACE modeling, mapping, and consequences at the production center. He leads a team of engineers who develop dam breach modeling inundation areas for all USACE dams for emergency action plans and consequences. Welcome to the show, Russell.
Thank you.
So, Russell, how long have you been here at the Tulsa District?
I've been at Tulsa District for 35 years, actually. This was my first job right out of college, and I've been here ever since, all in Tulsa District.
So, you didn't start off with the Dam Safety Production Center, I wouldn't think, right?
No, I started off in hydraulics branch, came in as overhire, actually after the 1986 flood that happened in Tulsa. Hired right after that in 87. A lot of work that was generated due to that flooding and that situation, a lot of flood protection work that was being done. And then over the years, about 2014, transitioned into the production center where we're still doing a lot of dam safety type work and elements like that. But all of it was in H&H and in the H&H water resources field, including what I'm doing now.
So you said you started about pretty much right after the 86 flood, or a little bit after the 86 flood. Where'd you go to college?
I went to college at Oklahoma State University. It was actually, my degree was in agricultural engineering. And when I was studying, I really was more interested, at least I thought, in ag products and power and designing of tractors and power systems. But the ag engineering curriculum there is actually really heavy in water resources, and I kind of took a liking to that. And when I graduated, then that kind of fit well coming over to the Corps of Engineers. I didn't know a lot about the Corps of Engineers at that particular time, but came over and did some interviews, and they had some openings, and it sounded like a great opportunity and something exciting and new that I thought that I should follow up with.
Were you were a young engineer right so you're brand new, pretty much engineer right out of college, and
that's right,
for the
yes.
Corps.
Uh-huh.
And there had just been this massive flood in 86. Was that kind of nervous? Did that make you a little bit nervous about, like, because you probably saw people like Greg Eastap at the time on TV or whatever, and talking about the flood at the during the press conferences and everything that they were having. Was it kind of, wow, this is going to be a challenging environment?
Yes, it was a little bit, because it's exactly like you said. You saw the news reports of what was going on, and then when I got in here and they said, well, you're going to be working with some of this, and there was some after action work that was going on at that time as well, which was fast pace and short duration. So there was a lot of activity, and it was centered around that, but it also centered around development of some new projects that were going in, kind of like the Mingo Creek project, which was one of the first things that I actually worked on when I got into Tulsa District. And that lasted for about 8 to 10 years before we got it all constructed. But no, it was a little bit, I'll say it was exciting, which was good. But a little bit kind of like throwing yourself into the fire a little bit. But there was a lot of support there. The people were great. It was a very good group of folks that were technically sound. And, I think it was a good learning experience from learning to see how they manage those activities from a fast-paced engineering standpoint.
The 86 flood, that was the holiday flood, right? The Memorial Day flood?
It was, yes.
Okay.
Yeah.
Because that was more of a stormwater runoff issue.
Right.
That's what led to Mingo Creek, right?
Exactly. It was a huge cell that dumped 15 to 20 inches over the Mingo Creek Basin, which is a pretty small basin, fast runoff. And yes, it was very dangerous. I think, very huge damages, killed a few people actually. So, a flash flood environment, which is a lot different than what we've seen on the last few floods, where we have notifications from dam releases and all, but still probably even more devastating in some ways just because of the flash flood nature.
Yeah, I guess like after that event, my understanding was that with when the Corps and worked with when the Corps and the state and the city worked together to try to address that issue following the Mingo Creek flood, they once the work was done, it was like one of the best or one of the model stormwater runoff systems in the United States, I think, right?
That's right. That coupled with what the city of Tulsa has done and in other parts of the city too, actually has yielded them a great FEMA rating, one of the best in the nation as far as flood control. And their part in what was done, at least in the Mingo Creek, what basin and what we were involved with directly was instrumental in all that was done. They wanted to have nothing but a Class A project, and the money that they put in to accelerate and to make things better from what the government would even put into it was really good. So we had a great sponsor from the local county and even the state level to make sure that they had a Class A project.
When did you? I guess we'll go backwards a little bit. When did you know you wanted to be an engineer?
Yeah, that was I haven't really thought about that too much, but it's a good question because I was actually working as a small engines mechanic, and then I turned over to a diesel mechanic in college while I was going through college. But I think all through that time, I had, like I say, an interest in tractors and power, and I was kind of in the agricultural uh, area as far as where I was working at that time at an implement dealership, working on things like that. So the agricultural part of it kind of came out, and along with that, I don't know, I just kind of like to know kind of how things worked. And I saw things, I thought, wow, if we could just change this or that, we could make a better system. And I thought, well, that kind of goes into the engineering part of it. And so when I started school, I thought, well, that was good. And they said, well, the engineers make a little bit more than the mech ags do. So I thought, well, let's try it. And it seemed to work out.
So you didn't have a. I guess it wasn't something where it was this really big daunting challenge idea that you brought up in your mind. It was more of a situation with I like engines. That's an engineering kind of feature, and the math you weren't scared about the math, and you felt comfortable with it, so you went forward and did it, right?
Right. I think it was more about what I thought I might like to do as far as the hands on part of it. Yeah, I wasn't thinking about what levels of calculus and all those theories that I was going to be doing. I wasn't taking extra classes in high school trying to prepare for it either. But um, like I say, you don't really think about those things, but you get into it, and then it kind of comes to you. You hit a kind of a sweet spot with it, and it feels right. And so I stuck with it, and got out on the 4-year program, so that was good. And I was glad I did it. It's been I've enjoyed all that I do, and that's what's keeping the work so interesting right now. Is because there's a wide variation of work that's I'm doing now. And so, the engineering part kind of falls even outside of what I do at the core. It's just kind of that thinking of how you look at everything that you see on a daily basis and how you approach it.
Where are you from originally? Where'd you grow up?
I'm actually born and raised in Stillwater, so I went to Oklahoma State University. So it was cheap and had a few scholarships going there anyway from the academic side. So it worked out well. I didn't feel the need to have to get away from my parents or anything at that particular time, at least not for a faraway trip. So, so that worked out well. Yeah.
So do you still go to the football games or the sporting
Yes.
events or?
I have family. Besides my folks, my brother lives over there as well, and I go back frequently. I've had season tickets for a long time for football. Try to make a few basketball games, and now I've seen the new baseball stadium that they have, which is a great place. I encourage everybody to go there and see the Cowboys. So no, it's nice going back. It's amazing how things have changed. Not even over the last 35 years, but even from the first 20 years. How things you remember, playing down a cotton field down by the river, and now that has turned into a McAllister's. But no, I go back there frequently and go on the campus a lot as well.
Right. They say, I guess it was Thomas Wolfe who said you can never go home, but you can always go back to your university and
That's
visit,
right.
right?
That's right.
Why did you decide to come to the Corps versus anywhere else?
Well, so there wasn't a huge market whenever I got out of school.
There wasn't a huge market for engineers.
For engineering.
Really?
I did have a few interviews with different elements. One of them was in air conditioning and some other high rise building elements. And I thought, well, I'm not really sure how I got the cut on some of those, but um, but the deal is that through all those interviews, in some ways, I was kind of glad that I didn't get chosen because I thought I couldn't see myself doing that type of work, uh, even though it all kind of felt, in that realm of engineering. And so the folks that were hiring, they were just looking for engineers, not specific engineers. So with the water resources background that I had there, when I came here, I don't know, it just seemed to fit. People were nice. It was an inviting atmosphere, and I felt like I think that was a great fit for me, and it just felt right at the time.
What do you do? You're you in your current role with the Dam Safety Production Center. Can you talk about what you do versus maybe what you were doing when you first arrived? I guess you said you worked in hydraulics and hydrology originally. And so
Right.
were you a water manager back? You were managing.
I wasn't in water management. I was on the what they call the hydraulic design section. So
Okay.
we did a lot of design elements. We designed a lot of features for flood control. I actually ended up doing some design for some of the spillways that we have, like at Canton, the rehab
Oh, yeah.
at Tin Killer and Skytook. I worked on all those design teams for that. Transitioning over to the production center was kind of I'll call it the modern age of dam safety started in the kind of the early mid 2000s. And so I was working with doing risk assessments on dams nationally, even outside of Tulsa district, and transitioning to the production center just kind of was about looking at dam safety as a whole everywhere. And so I still do. We still do design. The production center does do design and construction based on risk assessments of dams all over the country. We'll come up with a fix, and our group has been fortunate to lead several of those. Most notably, right now, the one at Louisville. We're doing some rehab down there. We're overseeing that. But also at Pine Creek, rehab down there of the conduit. Did a lot of design work on that, and so it's kind of the next level, I think, of flood protection. But I think it's interesting from the standpoint of you get to see how professionals across the USACE has been approaching this, even outside of the Tulsa district, which is kind of interesting. And I must say that probably what I've seen within the Tulsa district, we have some of the finest folks in here to work with and that are most knowledgeable of anywhere that I've seen in the country, uh, as far as it goes for dam safety and how to approach it. And so I think I've been fortunate to kind of help kind of push that direction. So I'm glad that we have a production center here in Tulsa. That's not something that every district or even every division has to this point. So I think that's a testament to the talent that we have here, within the Tulsa and the Southwest Division area.
You get to travel around a little bit, look at different dams, and see the difference in the way dams in other parts of the country were designed, right?
That's right.
So how different? I mean, is it interesting? Or is there like a lot of difference in we think of a dam, we just think of dam, right? But each dam, they're designed for specific geological and hydrological situations. So how different is it in maybe say like the eastern part of the country versus this part of the country?
Right. Well, it's all different, but yet it's the same. It's all about flood control. But I think the difference comes where you have the different configurations of gates and structures, and how to operate those. And that's the main thing, because there's some locations where you'll have to have fish passage, and things like that. Well, we don't usually have that here, so that's something new and innovative. And there's a lot of things on the coast where you have to do some coastal management features of even lakes and some backwater areas. But um, it's just kind of the configuration. Some of these dams might have been built in maybe the 40s, and we have a few of those as well, versus dams that were built in the 70s. There's quite a bit of difference between the assumptions that go into that as far as runoff, the approach to runoff, and how they may operate. Even though, like say, we're all about maximizing flood control is how it works. You also have navigation that plays in there. Fortunately, we have navigation here. On projects that don't have navigation, certainly that's a whole different operational aspect because they don't have to maintain minimum flows and have to worry about trying to get lake pool levels down to get traffic going again on the navigation system. So it's very interesting to see how those have been configured over the years based on all those different challenges they had at the time when they designed them.
Yeah, you don't. I mean, there's just it's just so there's so many different, I guess, configurations, right, of dams, and
Hmm.
um, when you also do some well, how you've probably been on a lot of PDTs over
Right.
the project delivery teams,
Hmm.
and where you look at you study something, or you study a particular area or
Right.
project, and then you make a recommendation about what you believe based upon that study is the best way forward.
Oh yeah.
And you talked about Canton with the surcharge, like you did some stuff with the surcharge gates, and
Right. Right.
how do those design ideas come down? Is that something that you as a team say, hey, we'd like to try these surcharge, I guess they call them no, not surcharge gates. What's the term?
Well, the fuse gates.
Fuse gates. That's
Right.
what I'm using surcharge. The fuse
Uh
gates,
huh.
excuse me. So is that something that it's somewhere else you've seen it, or there's data about it being used? Like how do you, because there aren't a whole lot of new dams being built, at
Right.
least not in the
Hmm.
United States. So something like a fuse gate, and you can explain what that is,
Sure.
but why would you make a recommendation like something like that? Where would that come from?
Right. So working with the fuse gates, that wasn't necessarily what we were looking to do when we started. The PDT got together, and we had issues with the PMF inflow coming off of Canton.
What
We
is
had to come up with
what
a
is
system.
PMFM?
Oh, I'm sorry. Probable maximum flood. So
Okay.
over the years, that anticipated maximum inflow has risen enough to where we had a dangerous situation out there potentially if you would get a PMF type event. And so we have to, in order to reduce the risk and get it within the current guidance, we had to come up with a way uh, to pass that flow. Now you have constraints to go with it, and this is all the PDD discussion. It's not a hydraulics issue or us coming up with a plan. This was definitely a PDT. The full team was in compliance about coming up with these several options. We came up with numerous options that we were looking at and evaluating based on a set of criteria, whether it be potential consequences downstream, upstream, raising the pools, raising the dam, coming up with new configurations of gates. But when a project like Canton's been there for so long, you have issues like you don't want to put additional flow down the system that they haven't seen in the past, and because that impacts things that in ecosystems as well as flood situations. So we started looking at some innovative ideas, doing a little quote brainstorming on this, and we did. There were some dams overseas that had incorporated the fuse gate system, and so we started looking into that a little bit, and that system is kind of designed such that you can still go ahead and maintain your operation through the full variation of the pool, and the only time that those would ever operate would be within essentially when you're just essentially right at that PMF level. So it had an advantage from that standpoint where you don't have to open gates real early in the system and have additional flow. So as that progressed, we talked to some folks, did some model testing, at Erdick and some different places on that, to try to see, if that would fit. We did it. And at the time, it was ended up being like the largest fuse gates in the world at that time when those were done.
The ones that can't.
Right, the ones with Canton. Now that they've built others since, but at the time we could brag a little bit on that. So that was kind of a fun, but it was a team decision, and it was one that we did have a little bit of background to go on as far as some test data and all that had been done as far as that goes. None of those had actually went through a system and fully went through the full level of coming up and then tipping and doing all the things that they're supposed to do, but we felt confident based on the model test and the engineering design behind it after we did our own computations on it that it was going to be an interesting and it seemed like a very viable solution to what we were needing at Canton.
Can you explain how fuse gates work for people who may not
Sure.
understand what we're
Right.
talking about here?
Right. So essentially, you just build at least on Kent, we built an offset spillway away from the current structure that we had. And in that spillway, we just put up essentially these fuse gates that end up being a solid concrete wall that holds the gate back. And then we have prescribed levels of actually Kenton has 8 different gates. Now these gates are like 40 feet high and about 60 feet wide. So they're huge masses of concrete. And so the way they work is at certain levels, when the pool gets at certain levels, a gate or a multiple gates will actually tip over and then allow flow to go through the entire section. So what it does is it allows you, like say, to operate the lake as normal through the normal range of pools, and only when you get to certain level, which is near that PMF level, which you're releasing so much water downstream, you're just trying to make sure that you don't have overtopping or something
When
catastrophic
you
occur
open
at
it
the
up?
dam, right? And so you'll tip one or two of those dams to alleviate it. If it continues to rise, you'll tip the next two, and so on until all 8 of those gates are tipped, and you have an open spillway that's releasing flow downstream.
And that basically slows down that flow, right? So that when you say it goes downstream, it almost creates I guess another pool, right? Because you've got this.
Right. Well, or it's helping alleviate the rising in the pool at Canton because at that point we're at what we term our max pool. And so those are meant to tip so that you don't continue to rise above your maximum pool and have some issues or have a compromise of the actual dam itself. Now you are putting additional release downstream.
Mhm.
But like I say, at that point you're already to the point where you had the normal operation is occurring and you're releasing hundreds of thousands of CFS downstream already. And there certainly is awareness and there's flooding occurring downstream so you're adding to it, but being able to incrementally tip these then allows that rise of flow downstream to have smaller increments so that it's less likely to catch someone by surprise or cause additional consequences other than having a whole set of gates or a super wide gate open and then release this new flood wave downstream. So certainly a benefit of doing multiple gate tippings like that.
What are some of the other projects you've worked on over the years?
Well, the other one was at 10 Killer Spillway, built an auxiliary spillway there. It was a gated structure, much like the original structure. And we did have an approach channel built it just right adjacent to the original one. There was some additional modeling that had to be done with 2D elements and trying to make sure we could feed that. And that's actually been a really nice structure. That one hasn't been operated other than just a test and all, fortunately. But that was a very interesting project just because that was the first time that we kind of utilized some 2D type modeling here. And then also at Skytook, rehab on that one was essentially that was a highly erodible spillway that had seen some erosion over the years. And so essentially it was just kind of concrete lining just to kind of help protect the and stabilize that spillway some. But it had multiple levels of of how it flowed down off the hill. We just didn't take it as a straight. We tried to utilize the topography to kind of help dissipate some of the energy throughout that system as it goes through. And that one was unique because we did create I'll call it a tailwater pool on the downstream side to help with that final jump and dissipate the energy down there, which is kind of unique because that outflow really doesn't maintain much tailwater down there. So we haven't ever had spillway flows there as well. We have been within by a foot or two of that spillway here just a few years ago,
Weren't we
actually.
in 19? I think we were pretty close.
I
weren't
think
we?
so, yes, and I think that was the max pool, but it's never went over that spillway, right?
What do you say is the biggest misconception maybe people have about engineering
About engineering, huh?
or about being an engineer?
Well, that's kind of a hard question. I mean, engineering is kind of stereotypical sometimes when you see it on TV, the pocket protector and some of that. But engineering is not really like that at all. I think when you really start talking and getting into it, talking to the folks, it's more about how they think and how they want to solve things and come up with solutions. It's about that. Now, there's a lot of smart folks, that are engineers as well as in other fields as well. But it's all about what's the problem and how can we fix it.
Yeah, like do you ever watch the Scott Adams Dilbert
Oh yes,
cartoons?
sure.
You ever feel like
Exactly.
that's
Yeah,
kind
there's
of like
lots
the
of those cartoons up
his
all over.
yeah, his characters are the sort of the stereotypical engineering, the kind of idea of an engineer, but I I don't I don't know of a whole lot of engineers like that. I know a few, but
Uh-huh.
most engineers I've met are pretty socially they're pretty socially grounded. I I haven't seen too many people walking down the hall looking at the floor, right?
No, I think no, it's definitely you're right on that. I mean, they're just like everybody else. You can't tell them much difference. I mean, now you might if you talk to my wife or my kids, but
My
good.
my college buddies were engineering majors when I was in college, and they were some of the most fun people I've ever hung out with. Maybe that says something about me, but we had great times together, and
Well, it helps when I'm putting together toys for Christmas. I know that because nobody ever wants to read the instruction sheet but me on how to put it together. So,
and you can actually decipher it.
yeah.
Yeah, I remember having when we were expecting our first, and my wife and I went down to we picked up some. I won't say the name of the furniture company, but you have to put their stuff together all the time. And and
Right.
I after putting together the chest of drawers, that I told my wife, I said, I'll never do this again. I'll pay the extra $200 for somebody to come and like put or just to buy one that's already put
Right.
together.
No, that's half the fun putting it together. So.
Right. For engineers especially, right?
That's right.
When you say consequences, what is that?
Right. So, it ties back into dam safety again. Actually, I always refer to it to as the MMC, modeling, mapping, and consequences, and that actually was developed back in 2009 in USACE, and that was part of what came out of dam safety was that all districts and divisions were creating inundation maps for EAPs, but they all look different, and there wasn't really a true standard on how those were applied and how they were computing consequences from a dam breach. Consequences being damages, but also being life loss, which is one of the critical elements for that we use in evaluating risk of each dam. So,
Yeah, you could literally have a dam that's in physically worse shape than another dam, and because there's a greater population downstream of the other dam, right? Like
that's right.
it could have the rating as far as it's a is going to be what, lower or higher?
Well, it'd probably
If
be
it's good, it's
actually a lower rating,
right.
but
Okay.
But yeah, that's exactly why the MMC was developed, coming out of the Risk Management Center, was to get consistency with the objective. The initial objective was to come up with a common set of rules to evaluate each one of the dams to try to see where they rank against each other so that we could put the money where it needed to go first. Yeah, certainly it's like you say. I mean, we know we have dams that have problems, but if they're out in the middle of the country and there's, no sizable consequence or life loss potential, then if you have one in the middle of Dallas or Tulsa or somewhere where a breach is going to, take, thousands of lives, then those rank quite differently as far as where the money should go to repair those. And that's where the MMC came into to respect. So we have completed the whole portfolio of dams, which is like 752 dams within USACE, and have those ranked, and the Risk Management Center then is evaluating based on that. And it's about creating the inundation maps for development of the EAP, but it's also about providing information, like I said, for the ranking. Also, we worked with Homeland Security, and how they evaluate and look at each one of those dams about where their vulnerabilities are, and how that could impact critical infrastructure within the USACE as well as within the whole United States.
When you talk about inundation, is it essentially saying what's going to flood or what's going to get wet? How would you describe inundation?
Right. So I'll call it inundation. Looking at a map, it's where it's blue. Where's the water flooding? Now it floods at various depths too, and the map sets that we have now show that, because that's a very important thing. If you're right on the edge of an inundation area, that's where essentially where the depth is zero, right? But we know that maybe 100 foot from you, the depth may be 10 or 12 feet, or maybe at the rooftop of a house. So that's important. So we look at full extent, but we also look at depth, and the depth, the velocity, other hydraulic features within that inundation computation that are used to come up with estimates for consequences and life loss, and how can people get out, how fast can they get out. There's a lot of things that go into it to try to do that computation.
What is the most exciting part about your job? I mean, obviously there's a lot of anal analysis that you're doing, and you're
Mhm.
looking at data and maps, and what what's most exciting about it or enjoyable? I'll just
Well,
say enjoyable, actually.
well, I mean, I think it's kind of both. Is that there's just so many things that you can work on, that the work is diverse. I know it may sound monotonous, or if you're just doing inundation maps daily, but then, like I say, every project that you work on is so different that you have to approach it differently. Even though you're creating the same product, it's still different in its own way, and it's exciting. Plus, the fact that some days we will get requests from some overseas. You have hurricanes, a lot of things like that that we will work with to come up with inundations, or impacts for those areas, to try to give them estimates so they know where to evacuation should take place and things like that. So those short term, fast paced elements are actually exciting. And not everybody wants to do that, but I think that those are exciting, at least on the short term. Nobody wants to do that, week after week after week. But certainly, I think those types of things make it exciting, just working on different types of projects and different time frames. Yeah.
Is there a dam in USACE which you'd say is probably your favorite, like structurally, or is there one that you just think is more impressive than any others?
Wow, that's it's pretty interesting. I've worked with so many, but I'd say Bluestone Dam in West Virginia is a pretty interesting one, just from the aspect of it being built like in the 20s, and it has some very unique features. But I'll say even that Keystone Dam is actually kind of unique in its own way as well, especially with the population that it has downstream. And it's just a very interesting dam, and you'll actually see Keystone, the Arkansas River, and all these elements in a lot of publications that have been done because it's actually been used, and this basin's been used quite a times for pilot studies within USACE for the MMC as well as risk evaluations
Oh
too.
wow, I had no
Yeah.
idea.
Mhm.
So it's one of those
Right.
go to structures.
For hydrology and hydraulics, yes. So
You when you were preparing your pre-interview stuff, you were asked about I guess to provide a quote, and you provided a quote from Theodore Roosevelt about believe you can and you're halfway there.
that's right.
Why that quote?
Well, I've thought that for many years because it's very cliche in a way. Yet, but if you don't have any type of vision or think that you can do it, or you don't believe in yourself at all, there's really no way you're going to get there. So you have to have that first, because that's what's going to give you the drive to do the things you need to do to exceed or reach your goal. And so I don't know. I just read that the first time. I don't even remember where I saw that first. It was like in high school sometime. Probably was doing some study that I probably was interested in much, and saw that, and I thought, wow, that's really cool. And so I've just kind of adopted that, and I still think it still applies today. I mean, I still have goals that I want to attain, and I'm thinking, well, if I'm going to get there, I'm going to have to believe I can do it and set a timetable and then try to get there.
It's interesting how some quotes will speak to us more than than others. Whether they're well known or
Right.
I wasn't actually. I mean that quote sort of speaks for itself, but I
Hmm.
wasn't actually familiar with that quote.
Hmm.
It seems like something Teddy Roosevelt would have said, though. Definitely.
Yeah.
um, what have I not asked you that I should have probably asked you in this interview?
Wow. I don't know.
Was there a topic you were thinking, I hope I get to talk about this, and he didn't even ask it. He didn't cover it. There's usually something like that.
Yeah, I don't think so. I mean, I think when I was thinking of my career, since being here for what 35 years in March, and I think back, I really think it's about the people, that make this fun, that make it exciting, that make the projects good. All those questions that you asked, I still think it comes back to the people. And so I've worked with a lot of people across the country, working on all these different dams, and you know, you certainly don't see the government worker uh, cliche, on that. I mean, the the people that I've seen in the federal government are, some of the finest and most technically sound and eager. They all want to do a good job. They want to do it efficiently, and they want to do it right. And I've seen that in all areas, not just in engineering, but the people I deal with that do admin all the way, to the executive office, I think have that same vision now. And I'd say over the course of my career, I've seen that get better.
Really?
Yes, I've seen that get better. I know that when I started in Tulsa District, right now we're about half as many people that we were when I started in '87, and I think about the work and the products that go out now, and I'm like, well, they're tenfold of what was being produced, 35 years ago.
That
And
took more people to do
yeah, so yeah, and we're
because of
doing it
the
with half the
technology.
people. We're doing it with half the people.
Right.
And certainly there's computers and all that go with it, but there's also folks that want to do work and they want to do it right, and they have fun doing it. And I don't know that many people that are complaining about being here. It's an exciting job, and they do it. So I think it's I would recognize that it's the people of the Corps of Engineers, that make this a good job, for me and probably for other people as well.
So in your 35 years almost or more here, you've seen a lot of people, new people come in, and you've seen some
Mhm.
people leave. for someone who is graduating college and they're a young engineer and they're considering their career path, what advice would you have for the young engineer who's considering a career somewhere?
Yeah. Well, I've actually given that to a few people, and it kind of varies to kind of, but it always comes back to, you're going to have to find something that you like to do. Make sure it's something to do. Now, the first year or two, here's the deal: you're not going to know what you really like and what you really want to do until you start doing it. So I said, you got to be open. You're going to have to go there, but then you're going to have to find and think about, is that what I want to do? And then if you do, then you're going to have to try to find a way to to motivate that thing that you do to make it unique and make it exciting, and then build on it, within that community. But you got to be open at first, but then you got to make sure that it's fun, and make sure that the people you're going to work with are going to be fair, and all. And I think, coming into to USACE, I mean, that, there's hardly anywhere that's going where you're going to be provided the resources to excel when you talk about, training and the various levels of products that we do as far as engineering goes. Everything from, pre to construction, so we do it all here. So there's really not something that you can't do here, whether it's mechanical, hydraulic, or structural. And like I say, we go all the way from design to construction.
Yeah, you do get a lot of opportunities to branch out and explore disciplines or areas within disciplines and
Hmm.
working for the Corps, right?
Exactly. Now, I made a decision. I guess it was kind of a deliberate decision. When I was working in H&H, I had opportunities to go to some other areas, but I don't know. I was really liking it, and the work was diverse. And I thought, well, I'm gonna stick with it. And then as I stuck with it, like I said, I've been an H&H branch my whole career, so I've done, H&H is all I've done. But doing that has allowed me to kind of become more of an expert in that area here, and so that's afforded good things for me, and others, like to move around. You have that flexibility. That's good. It's good to be well rounded. So you can do it either way, and you can still excel. Within the core.
Well, Russell, I really appreciate you taking the time to sit down and talk to us and take time out of your day. You all are very busy, especially in this current era. Thank you for joining us for Corpstruction. Corpstruction is a production of the Tulsa District U.S. Army Corps of Engineers Public Affairs Office. This episode is brought to you by the Dam Safety and Production Center of the Southwestern Division. Thanks for joining us. Have a great day.